So predicting the geometry, what will happen if, what will be the geometry if there are three bond pairs and one lone pair? Then we call that as a trigonal pyramidal with a bond angle of 107. So example like NCl3, PF3, ClO3, H3O, they all have a trigonal pyramidal structure. Like when we draw for H3O, first the bond like oxygen forming a bond with hydrogen, a normal water molecule, but there's a dative bond. So when you check how many bond pair, the central atom is oxygen. How many bond pair? One. The dative bond is also considered as a bond pair when predicting a geometry. 1, 2, 3. So three bond pairs are there on the central atom. And how many lone pairs are there? There is one lone pair. Then the geometry will be trigonal pyramidal. So to draw this structure, trigonal pyramidal, you can see the same way as we did for tetrahedral. One of the bond is into the plane, another one is out of the plane, one in the same plane, and there's a lone pair. So how we draw with a bond angle of 107. So oxygen, one of the bond in the plane, in the same plane, one is out of the plane, like into and out. If you remember magnetism of electricity and magnetism, we say into the paper or out of the paper. So this is the same manner, like one bond is coming out like yours and one is in, and there's a lone pair. And what is the bond angle? Bond angle is 107.5 degrees. Another example for this, like PCl3. Phosphorus belongs to group 5. So it is having 5 electrons. One is shared with chlorine one side, then another is shared with chlorine, and 3 chlorine atoms here. So when we compare the bond pairs, there are 3. When we compare the lone pairs, there's one lone pair. So what will the geometry from this? We can say it is trigonal pyramidal with a bond angle of 107. And how we show this? So the lone pair, one is in the same plane, one is into, another one is out. Is it clear, the structure of PCl3 predicting the geometry? Then if it is having 2 bond pair and 2 lone pair, then we call that structure as bent or V shape. You can say bent also, or you can use the term V shape. So, but it's condition there should be 2 bond pair and 2 lone pair. So example, like normal structure of the water, H2O when we predict the geometry for water? So water is H2O. When you draw the structure of water, dot and cross diagram for water. So oxygen, the central atom, hydrogen is surrounding it. So you can see clearly the central atom is having a number of the bond pairs, 2, and number of lone pairs, also 2. So when 2 bond pair, 2 lone pair, what will the structure? Structure will be bent. How we draw this? Means we reduce, and this is how we represent with a bond angle of 104.5 degrees. So actually you can see each lone pair reduce the bond angle by 2.5, because in a tetrahedral structure, when we were having 4 bond pairs, in a tetrahedral, when we have 4 bond pairs and there was no lone pair, the bond angle was 109.5. But in trigonal planar, trigonal pyramidal, the bond pairs are 3 and the lone pair is 1. So total 4 electron pairs are there, but out of total 4 electron pairs, 3 are bonded and 1 is lone. What was the bond angle? 107. So you can see 109.5 minus 2, 109.5 minus 2.5 will give 107. And if we have a bench structure or a V shape, how many bond pairs are there? 2. How many lone pairs are there? 2. Total are 4, including bond and lone, but 2 of them are bonded, 2 lone. What is the bond angle? 104.5. So 107.5 minus 2.5, you will get 104.5. So each lone pair reduce the angle by, or decrease the angle by 2.5. Because the repulsion between the lone pairs, like 2 lone pairs are repelling more, that's why the bond angle is decreasing. So greater the number of lone pairs, smaller the bond angle. And if it is having a 5 bond pair and there is no lone pair, then it is called trigonal bipyramidal. Why bipyramidal? Like it's making 2 pyramids, one up, one down. Like it's like making a 2 pyramids. Or that's what it's known as bi. Bi means 2, and pyramidal, it's like a shape of a pyramid. And if it is having 6 electron bond pair and there is no free, then it is known as octahedral with a bond angle of 90 degrees. So PF5 or PCl5 or SF6, PCl5 is trigonal bipyramidal, whereas 6 electron, it will be octahedral. So you have to learn this table, and better you just learn these examples as well, so you can recall the idea easily if you remember the examples as well. But it's not necessary like memorize, but you should know these bond angles, the geometry, and the shape. Then what is a metallic bond? The bond which is formed by a electrostatic attraction between the positive ion and the free or the delocalized electron. And metals, metal within the structure, like metals have a layer or lattice of a positive ion and the free electron. And the 3 main factors that affects the strength of a metallic bond. Number 1, number of the proton. Greater the number of protons, stronger metallic bond. Number of delocalized electron per atom, like how many electrons as you can see, sodium is having one delocalized electron per atom. But if I take aluminum, aluminum is +3. So more positive, more protons are there, and plus 3 electrons in the 3 delocalized electrons. So it will have much. So stronger force will be there. And size of the ion, size of the positive ion should be smaller, so it can attract the electron easily. That's why, like when we compare size aluminum ion with magnesium ion, uh, with sodium ion, these all are isoelectronic because 10 electron. But when we compare the size decreases. So aluminum size is much smaller as compared to magnesium. Magnesium size is much smaller. Sorry, aluminum is smaller than magnesium, and magnesium is smaller than sodium. So which one you think have a stronger bond, metallic bond? Sodium, magnesium, or aluminum? Which one you think will have a stronger metallic bond? Sodium, magnesium, or aluminum? Aluminum with a +3 charge and smaller size of the ion. So aluminum will have a stronger metallic bond as compared to magnesium or sodium. That's right. As you can see the structures. This is a comparison, the bonding and structure, just a quick review of the bonding. It can be, what is the ionic bond, which is an electrostatic attraction between oppositely charged ion. They are giant ionic lattice like sodium chloride, magnesium oxide. And then this ionic lattice, we discussed many definition, like what is the meaning of ionization energy, electron affinity, atomization, lattice energy, and then why there's a difference in theoretical and the practical lattice energies. Then a bond which is formed by sharing of electron is called covalent bond, and this covalent can be simple, it can be dative. Simple means when it is coming from both atoms are sharing electron, and dative means when both of the share electron from one atom. And this covalent compound can be simple. When it's a simple covalent compound, they have a, about the intermolecular force, we will discuss in unit 2 about these intermolecular force. That's why I did not discuss anything in a. Then the covalent molecule can be simple, it can be giant. Giant have high melting and a boiling point, high density. And then the last one, metallic, electrostatic attraction between positive ion and delocalized electron. They have a giant lattice. Example, like all the metals have the same structure. These are comparison of the properties. I will share this slide with you, so this presentation with you, so you can go through this all. Now we'll do some questions, so it will improve your understanding of the topic. And mainly we'll discuss, we already discussed about the lattice. So our main focus is on covalent compound and covalent bonding. Question 35, what could be the answer? Which diagram best represent an electron density map of a chlorine molecule? Electron density map for a chlorine molecule. Yeah, what's the answer? A, B, C, or D? First thing, it cannot be C or D because that's for ionic ions. Because you can see the separate contour lines are there, electron density maps. That's for ions. So you're left with A and B. Now, which one is the correct answer? It's a chlorine molecule, so it's a simple covalent compound. What could be the right answer? Here, A is the right answer. Why A is the right answer? Because what happened, what it shows, these lines are representing the electron density, means I can find electron anywhere within this region. Maximum probability or chance is there finding electron. But this shows that electron can be here or here, not between them. Most of the questions are related to ionic bonds and difference between the lattice and why there's a difference between theoretical and practical lattice energies. Ammonium ion contain a covalent bond and a dative bond. Describe a difference between covalent and a dative bond. So what is the difference between covalent and a dative bond? A covalent bond is formed by a sharing of electron, and both of the electrons are, means the bonding or electron comes from both atoms. But in a dative bond, the bonding electrons come from one atom only. So in a simple covalent, bonding electrons from both atoms, where dative, the bonding electron from one atom only. Draw dot and cross diagram to represent a symbol for ammonium ion and for outer shell electrons. So how we draw the structure? As we already discussed, like example, nitrogen. Cross for hydrogen we have to use. So you have to use the same symbol. And dot for nitrogen. And there's a lone pair. And the hydrogen attracted, so there will be a positive ion. This is a dative bond. Suggest how the electron density map of ammonium chloride would provide an evidence for the presence of ions. Look, what is ammonium chloride? Means ammonium ion will be there. Ammonium chloride is having ionic bond and covalent bond as well as dative bond. What is the ionic bond? Because there is an attraction between a positive and negative ion, so there will be ionic bond. Dative bond, because there is a dative bond between nitrogen and hydrogen. And covalent bond, also there is a simple covalent bond. So it contains all three bonds. But how X-ray diffraction or electron density map shows that evidence of the presence of ion. So whenever there is an ionic compound, when we draw the electron density map, so electron density contours or electron density lines will go around ions, not around the nucleus. Means, so if it was a covalent structure, like example, if ammonium chloride was covalent, then what should be the electron density map appear or look like? It should be like this. If it was a covalent, but this is not covalent, so there are separate lines for electron density lines for positive ion and separate electron density lines for negative ion. So the electron density map, how it shows that it is ionic, not a covalent. So you will mention electron density lines go around ions, not around nucleus, or do not overlap, or do not fuse, or do not intersect, or there is a gap between the particles. So there is no electron density lines. Because there are no lines, so there is a gap between the particles. Is it clear? This part? So using electron density provide you an evidence, and how it is done by X-ray diffraction. So provide you an evidence that whether it is a covalent bond or ionic bond. Which species has a dative covalent bond? Question 47. Which one is having a dative covalent bond? What's the answer? Yeah, A is the right answer. Hydroxonium, HH3O. Question 51. Which of the following observation provide the best evidence for the presence of ionic bond in unknown substance? Like best evidence that the substance is ionic. That's right. The molten conduct, but solid does not conduct. It shows that because it is conducting, so ions are there. And we predict that because in a solid, the ions are tightly packed together. Now, draw a diagram to show electron density in both parts of double bond between carbon atom of ethene, and label region with appropriate symbol. So we have to draw electron density map for carbon-carbon double bond in ethene. So how we represent only for carbon-carbon double bond is there. So two carbon atoms, these contours. And you will mention like the bonds here, double bonds. Same way you have to, like, if you remember, see this part, the structure of chlorine was there. Same manner you will draw, but more lines as compared to that of chlorine. The bonding of sulfur dioxide is represented. So you can see double bond is there between sulfur and oxygen, and dative bond. Complete a dot and cross diagram. So dot and cross, so if sulfur, because there are double bonds, so 1, 2, and 1, 2. Then oxygen is having 6 electrons. Oxygen is stable. What about sulfur? So total oxygen is having 6 electrons. 2 are involved in the bonding, remaining 4. But for sulfur, because one is a dative bond and both electrons are from sulfur, so it will left with 1, a pair of electrons. So both oxygen are stable, but what about sulfur? 1, 2, 3, 4, 5, 6, 7, 8. So sulfur is also stable. Now what will be the, so this is how we represent, like one of them is a dative, another one is a covalent bond, double covalent bond. Is it clear, this structure? Structure of sulfur dioxide. So this is a question about the structure of the substance. Predict predict HNH bond angle in NH4 and HOH bond angle in H3O. The first thing, you cannot predict without drawing the structure. So first, when you draw the structure for NH4, so what is the structure of NH4? There are 3 bond pairs for 3 covalent bonds and 1 dative bond. So how many bonds are there? You can see 4 bonds, because dative bond is also considered as a bond. So 4 bond pairs are there. So whenever 4 bond pairs are there, if you check the table, if we have 4 bond pairs and there is no lone pair, then it will be tetrahedral with a bond angle of 109.5. So when you predict this structure and the bond angle, so it will be 109.5. When H3O, you are predicting one is the dative, and still 1 lone pair is there. So 3 bond pair and 1 lone pair. So 3 bond pairs are there. 3 bond pairs are there and 1 lone pair. So it will be trigonal pyramidal with a bond angle of 107. So the first one was 109 tetrahedral, and the second one is 109.5 tetrahedral. Now name the shape. What is the shape of BF3 and PH3, and explain why they are different. For BF3, boron trifluoride, it is having 3 bond pair and no lone pair, so it will be trigonal planar. But in PH3, phosphorus belongs to group 5. So it is sharing 3 electron, like means 3 bond pairs are there and 1 lone pair. Because it belongs to group 5, so it shares 3. And 1 lone pair is there. So what will the difference? 3 bond pair and 1 lone pair. Then it will be trigonal pyramidal. What is the bond angle? 120. What will the bond angle? 107 degrees. And why there is a difference? Because this contains only bond pair. So bond pair repulsion is less. But this contains lone pair and bond pair, and lone pair and bond pair repulsion, or lone pair repulsion is more. That is why the bond angles are smaller. Is it clear, this answer for question 58? Because PH3 is having a lone pair and there is a more repulsion for lone pair. That's why the bond angle decreases, or smaller bond angle is there. Any doubt related to the class? So I will end the session and share the recording with you.